Before we get started, if you haven't subscribed to the channel, please consider subscribing. Also, if you're interested in courses or books, or you have ideas on how to improve these content, please check out the link in the description box. In this video, we will take a look at the definitions of finite and infinite set as well as cardinality. A set that has a finite number of elements is called a finite set simply. The number of elements of a finite set is a natural number, which is a non-negative integer. The number of elements of a set is called its cardinality. So for example, for any finite set S, its cardinality is written like this, where cardinality of S is equals to n, which is a subset of the set of natural numbers. Now any set that is not finite is called an infinite set. Let's take a look at some examples. So here we have the set S, which is given by 2, 1, which has the elements 2, 1, 9, 5, 6, and 7. So it has 1, 2, 3, 4, 5, 6 elements. So cardinality of S is equals to 6 here. We have the set S is equals to 5, which is the empty set, and in this case cardinality of S is equal to 0. And then here we have the set S is equals to 0, 1, 4, 9, 16, and dot dot dot. So this is the set of squares of all natural numbers, and this is an infinite set. So now let's take a look at some useful properties of finite sets as well as infinite sets. So let's assume we have the set U and V, which are finite sets. So the union of any number of finite sets is finite. So here I'm writing with examples of two finite sets. So the union of U and V is also going to be a finite set, along with this property holding true, which is the cardinality of U union V is equals to the cardinality of U plus the cardinality of V minus the cardinality of U intersection V. So this brings us to the second property, which is the intersection of finite sets is also finite. And then here we have the third property, which is the Cartesian product of finitely many finite sets is finite. So if I take Cartesian products of a finite number of finite sets, then their product is also going to be finite set. So with two sets U and V, we write it like this, that the cardinality of the products of the product of U and V is equal to the cardinality of U times the cardinality of V. So this represents Cartesian product. If you remember the definition of a power set of any set is the set of all of its subsets, including the empty set and the set itself. So here, in the case of a finite set U, the power set of U with cardinality given by n will mean that the cardinality of its power set is given by 2 to the power n. And analogously, all of these properties hold true for infinite sets as well. So union of infinite sets is also infinite, intersection of infinite sets are also infinite, and so on and so forth for all of the other properties. If you like my videos and find them helpful, then please support my work by subscribing to the channel.